I'm Simon Marsland, the Hub Leader of the Climate Systems Hub, and I'm joined today by two of our scientists, Andrew King at University of Melbourne and Katie Quail at the University of New South Wales. And before we kick into it and start looking back at 2023, a year of extremes, just want to pause first of all and give an acknowledgement of country. I'm on Bunurong lands down here at the CSIRO in Aspendale. Got the beautiful sea country of Port Phillip Bay, a couple of 100 metres behind my back there. Got the beautiful wetland country of the Ramsar Edithvale Seaford bird sanctuary, about 1.8 kilometres directly in front of me there. So a nice bit of country to be sandwiched on. Paying my respects to elders past and present of the Bunurong people, but want to extend that to the Wurundjeri people. Andrew, you're up there at the Parkville campus of University of Melbourne, and also the Bedegal people, Katie up at UNSW in Kensington. So paying respect to traditional custodians and elders past and present on all those countries, and extending those respects to any Aboriginal or Torres Strait Islanders who might be joining us today, and ask you to pause and reflect on the country that you are on as well. Thanks very much. So let's get started. And my background's in ocean and sea ice modelling before I went into global climate modelling and subsequently became hub leader. So I just wanted to reflect a little bit on the ocean and sea ice this year, because it's quite remarkable, some of the extreme behaviour we've been seeing there. And I've pulled up a picture as demonstration there. There was a really, really hot Northern Hemisphere summer this year, and we saw that play out in the ocean. So you see the histogram of the last 45 years or so there. This has come out of Copernicus Climate Change Service, and this is the July global ocean surface temperature anomaly. And you see in 2023, it's over 0.5 degrees Celsius. And what does that mean? We already knew that, you know, in climate change, the extra heat coming into the Earth system, about 90+% of it, 93% or so, is going into the ocean, and it takes a huge amount of heat to warm the ocean up. So about 1,000 times more than to warm a equivalent volume of atmosphere. So when you see a really strong extreme like that, that's a lot of energy has come in and gone into the surface of the ocean. Another thing we know about the ocean is the warmer the surface is, the more efficient the ocean becomes at taking up heat going forward. So we're really starting to lock a lot of energy into the ocean, which will take, you know, be building up over decades and centuries to come, locking in climate change for the future. I think that's a remarkable figure. And associated with that is what we call marine heat waves, and these can really play out in the ecosystem as well through coral bleaching, damage to seagrasses, and many other ways in the biology of the ocean. And looking, you know, at a 34-year time series of marine heat wave area in the global ocean surface, and this one comes out of NOAA in the USA. You can see a few things on those curves there. The 97, 98 peak, the 2016 peak, two of the very strong ENSO years, El Nino years, sorry, I should say, over the past 40 years or so, where things really warmed up. But something really remarkable is happening in 2023, and indeed, they're 37% of the global ocean under marine heat wave conditions at that point in October this year. It ranks number 3 of the 400 or so months in that time series. The 2 and 1 are the months immediately preceding October. even if you, and that's the orange curve, if you take out the underlying warming trend of global warming over that 35-year period, you still see it ranking number 5 of the 400 or so months, and the other extremes are in those very, very strong El Nino years, once again, 98-9 and 2016-17. So we are seeing the signal of climate change very profoundly and very clearly in the ocean system. I want to turn to something that people may not, well, excuse me, this is the forecast for December, once again, coming out of NOAA, and just draw your eyes to the yellow spots there. That's where the forecast from start of December was looking at the months and saying, in the yellow areas, 90 to 100% probability of marine heatwave conditions occurring. And I've just spent a couple of days down in Hobart. You see that yellow blob off where Tasmania would be. Beautiful weather in Hobart this week. It was Monday, Tuesday, but meeting with our ocean scientists down there who are doing work in the hub on marine heatwaves. And yes, a lot of talk in Tasmania about marine heatwave conditions. The East Australia current pushing some really warm water down around Tassie at the moment. If you go back earlier in the year, the yellow was off the chart on large parts of the Northern Hemisphere in their summer. We are still waiting to see how things will play out for the summer ahead in Australia. Now for something people don't think so much about, perhaps. Called it Antarctic sea ice. It's really Southern Ocean sea ice. I want to thank Phil Reid at the Bureau of Meteorology for giving these slides over to me. He gave a very nice talk on what a remarkable year it is for Antarctic sea ice a couple of months back, and I reached out to Phil as a former PhD student I shared an office with. It's a wonderful thing about an early career scientist. You make some connections which are lifelong, and got a very prompt response. So thank you, Phil, if you're out there. The red curve there is the 2023, and on the left you're looking at the seasonal cycle for each of the years from 1979 to 2023. We have a very good idea of what the sea ice coverage was over those years, because the passive microwave satellites had gone up, and they can see very clearly where we are in ocean conditions and where we are in sea ice conditions by the reflectivity. The ocean is about 10% reflective or albedo, whereas the sea ice is about 90%. So quite confident in these pictures. And if you look at the red curve, you're missing in the winter there about 1 million square kilometres, the area of the Murray-Darling Basin of where you would normally expect to see sea ice. On the right-hand side, the individual years playing out again, but looking at the anomaly, how it varies from the mean of that time series. And once again, 2023 showing up as a very, very remarkable year. I don't want to get too mathematical, but that from Phil again is the standard deviation for across that 30-year or relative to a 30-year baseline from 81 to 2010. And you see in recent years and in this year has been out by 7 standard deviations on that minimum. Coming from a mathematical background, you would say, well, this is no longer normally distributed classical statistical stuff. There's actually something wrong in this time series. You would discard it and say, look for another cause of what's happening. So, something is quite remarkable has been happening in Antarctic sea ice over a period of years. Back in 2014, we had some very high maximums, but since then, and especially this year, very, very out of character behaviour of the Antarctic sea ice. I'm going to pause there because that's a couple of things I know about around the ocean and the sea ice, which I'm quite interested in. But I'm going to hand over now to Andrew, who is going to lift us up out of the water and into where people are living. And Andrew, please take the floor and share some of your perspectives on what a remarkable year this has been.
Thank you, Simon. So I'm going to talk a bit about some of the extreme events we've seen in 2023. Obviously, not all of them, because I only have a few minutes to speak, and a lot has happened this year. Just again for context, Simon's already discussed how remarkable 2023 has been. It's virtually certain to be the hottest year on record. And here's another one of these graphs, this time for global surface air temperature anomalies for September. And you can really see how September this year was just remarkable, so much hotter than previous Septembers, way beyond previous experience. And really in the second half of this year, as we've seen the El Nino building in the Pacific Ocean, we've seen global temperatures really starting to spike. And we've seen our first kind of proper exceedances of the 1.5 and 2 degree thresholds that are quite big milestones, obviously not meaning that we've failed to meet the Paris Agreement yet, because that's about long-term warming, but highlighting just how much trouble we're in terms of how fast we're warming the planet. So we've seen some really record-shattering extremes. And in terms of the global temperatures, this is a combination of factors. We've got this background warming trend due to our greenhouse gas emissions, but we've also got some other things coming together to give these spikes in global temperature, the transition to El Nino. We're still experiencing the after effects of the Hunga Tonga eruption, and we're also seeing reduced aerosols in the atmosphere, which means a bit more of the sun's radiation reaching the surface, and also slight increases in solar activity. And this combination is giving the spike in global temperature. But really, climate change is the big factor. So turning our minds to some of the extremes we've seen this year, obviously not discussing all of them because there's too many to discuss, but we saw really remarkable simultaneous extreme heat waves across the Northern Hemisphere, in North America, Europe, and China around July. We've also seen the devastating floods in Libya from a few months ago, and more recently, a transition from drought to flood in East Africa. Really quite exceptional drought and a transition to quite exceptional floods in a very vulnerable region of the world. In all of these cases I've just picked out, there have been rapid analyses, attribution analyses of these events that have highlighted substantial influences from human-caused climate change. And those were analyses conducted by the World Weather Attribution Group, led out of Imperial College, London. Some of those events I described are really affecting particularly vulnerable parts of the world, particularly the drought and floods in East Africa. And we see particularly devastating impacts of extreme events when they strike in poorer areas of the world. One thing we're seeing at the moment, the COP28 meeting is still ongoing, I think, unless it's just finished in the last few minutes. It's still ongoing in the United Arab Emirates. And whilst there hasn't been huge progress generally, we saw quite early declarations on the Loss and Damage Fund. But even though we're seeing progress on that, which is great, the fund's initial size is around $700 million, which is around 0.2% of the actual cost of climate change that's burdening low emissions nations. So we have a long way to go in really helping particularly vulnerable areas of the world manage the impacts of climate change, as well, of course, with the current discussion around reducing emissions, which the text and the meetings that are ongoing are looking at. So looking back to this East African event, we saw really bad drought build from 2015 up to this year, and then a transition to floods. And this is because this region of the world is really experiences a lot of variability related to El Nino and La Nina and Indian Ocean conditions, much like Australia does. But in East Africa, it's kind of the opposite influences, where El Nino conditions tend to bring wetter weather to East Africa and are more likely to cause floods. So we had drought build over several years when we had an absence of El Nino conditions, and this drought was intensified by human-caused climate change. And we've seen transition to floods with the switch to El Nino, and also exacerbated by human-caused climate change. One particular challenge in this area of the world is with observational data. The graph here in the top left shows a rainfall time series over October and early November in East Africa for different observational data sets. And you can see that they don't really strongly agree with each other. It's also a particularly vulnerable region of the world to extreme weather. And there's an estimate of around 40,000 people having died due to the drought over the last few years. So very different challenges from those that we see in Australia. And it's really important that we try and improve capability to manage extreme events, working with scientists in the global south. Turning our minds to Australia, we have different challenges, but we have seen plenty of extreme weather this year. Just picking out a few examples, we saw a very warm winter, especially late winter and early spring, and unusually dry conditions as well. In October, we had major floods in eastern Victoria, in Gippsland, and also more recently in parts of New South Wales and Victoria again. And just very recently, we've seen significant heat. Last weekend, we had really extreme heat across much of New South Wales, including in Sydney. So I thought I'd touch on a hot topic at the moment, which is to do with the seasonal outlooks. And I think there's this tendency when we have El Nino events and Indian Ocean conditions that are conducive to dry weather to kind of assume, it will definitely be dry everywhere, and just to expect extremely dry conditions. And if we look at the seasonal outlook, we saw for spring from the Bureau, we can see a forecast for fairly dry conditions over most of the continent. And then if we look at the actual rainfall decile map, it was actually quite dry for much of the continent, including the places where the strongest signal was in the seasonal outlook. So certainly not a terrible seasonal forecast at all. And I think a lot of people might be forgetting just how dry September was across Australia, and actually October, aside from in eastern Victoria. So it was still a drier than average spring for Australia as a whole. But this does point to the challenges of how we communicate seasonal outlooks, and with the challenges that individual weather events can bring in terms of appending seasonal outlooks. And when you've got a dry seasonal outlook, you just need one or two very wet events. In some parts of Australia, that will be enough to bring the rainfall up over average. So I think there's a challenge in how we communicate seasonal outlooks and how we communicate how climate modes relate to the weather we experience still. And just finally, thinking about the extremes we saw in the Northern Hemisphere this past summer, we saw some really record-shattering extreme events. So just for example, in China, the all-time temperature record was broken by more than 1.5 degrees Celsius. So that's a huge margin to break a record by. And it's useful in the Australian context to think about what a similar kind of extreme event could look like, and how we would be able to cope with that. And it's easiest to do this for extreme temperatures, where we have a really clear trend due to climate change. We should be expecting to break records and possibly shatter temperature records. We know from our climate modeling that it's possible, even in the current climate, it would be a rare event, but it would be possible to see 50 degrees in parts of Sydney and Melbourne. And this becomes increasingly likely as we continue to warm the planet. And if we were to experience that kind of heat, that would be beyond current records in many parts of Sydney and Melbourne, well beyond those records. And it's useful to think about how we would cope with that. We need to better manage extreme heat, and we can learn lessons from other parts of the world, including in Western Europe and in India, more recently, where we've seen big reductions in heat-related mortality. And I think as we face this coming summer and the possibility of extreme heat, we need to be thinking about that. Thanks.
Thank you, Andrew, not just for what you shared with us there, but in terms of some of those events, but the insights you give around that of what it means, and also in particular for today's audience, the insights that you have on what it might mean for what's coming ahead of us this summer, really appreciated. And I'm sure we'll come back to that in the question time. But now I would like to introduce Katie Quail from Climate Change Research Centre, one of our early career researchers within the hub. And I hand the floor over to you, Katie. Please take it away.
Thanks, Simon, and good afternoon, everyone. So today I'm going to share with you a little bit about my research, which involves working with traditional owners. I'll give some reflections on what those experiences have been like, and as well some reflections on the recent WCRP conference in Rwanda. So the aim of my research is to quantify the impact of climate change on right-way burning in the Mimal land management area. For those of you unfamiliar, right-way burning refers to the traditional fire management practices that Aboriginal and Torres Strait Islander peoples have been using to manage and look after country for thousands of years. It involves cool burning early in the dry season, which then helps to prevent hotter, more damaging fires late in the dry season, with the overall effect of reducing greenhouse gas emissions and therefore generating carbon credits. Through these burning projects, they've been really beneficial for these First Nations communities. It's provided a source of income, which has allowed for self-determination opportunities, employment opportunities in really remote areas, an opportunity to care for country, and all of this has been shown to increase well-being and physical health outcomes for First Nations peoples. So right-way burning involves the use of traditional indicators. I'll just go back one slide, which are used to know when to start and stop burning. So what you can see in the background of this slide is an example of one of these indicators. It's spear grass that has been knocked down by what is referred to as the knock-em-down rains. These are the final rains of the wet season. And so when they knock down the spear grass and you walk around and you see it looking like this, that's a signal that it's coming up to the right time to start doing these early burns. But what we know, what rangers and traditional owners are telling us is that climate change has been starting to have an impact on these indicators. They've been noticing that these indicators are not happening at the times when they'd usually expect them to occur. So what I've been doing in this project is working in partnership with the Mimal Rangers. They're an Indigenous ranger organisation based in Bullman, which is in central Arnhem Land in the Northern Territory. And together, we've been working to try to quantify the impact that climate change is having on these indicators so that they can better understand these changes that are occurring, and then, if necessary, plan and adapt their burning practices so that they can continue doing this really important burning for many more years to come. So the research has been divided into 4 phases. To begin with, there was the initial engagement and co-design phase. This involved me going up north for several trips to meet with the rangers, get to know them, start building those relationships, and planning the research together. Once we were happy with that plan, we then commenced data collection. So I went up again, and the main form of data collection was through yarning, which is like a semi-structured interview. That's what you can see in this image in the bottom left. So I conducted this yarning with the rangers and traditional owners and elders from the community to document their traditional knowledge of the indicators used for right-way burning at Mimal. And then I was also lucky enough to have the opportunity to observe and participate in some on-the-ground burning and aerial burning. After documenting their traditional knowledge of these indicators, I moved on to the data analysis phase, where I matched these indicators with climate variables that we can then input into our climate models. So for this project, I'm looking at an ensemble of models from the Cordex Australasia projections. And this allows us to look to see how these indicators might be changing under different emission scenarios for the future. So once that analysis is complete, I'll be going back to the community to firstly share the results with the rangers, and then with their help to share these results with the wider community. So I'm currently still in that data analysis phase. So I thought today, instead of sharing with you the preliminary results, I would talk to you a little bit about my experiences working with traditional owners on this project. So I think just to firstly say, it's been a fabulous opportunity to work with traditional owners. They really do have an incredible wealth of knowledge, and it's really important, I think, moving forward, that we are incorporating these knowledges into our climate science. But it is a very different experience than working with other stakeholders. So the first thing I'd like to note is that relationship building is really, really important. You know, usually you make an agreement to work together and then you just go ahead and start doing the research. But with traditional owners, even once we had that agreement, it wasn't until probably my third trip up there that they actually felt comfortable enough around me to start having in-depth conversations about burning. So it is a time-consuming process, but it's well worth it. The next thing I would say is yarning. It has a lot of similarities to an interview, but there are major differences. So with yarning, there's a big emphasis on the social side of the yarn. So making sure that everyone is feeling comfortable in that space. And then when asking questions, I found a lot of the time the responses tended to be in the form of storytelling. So it may seem initially to be off topic, but if you're patient and stick with it, I found that these stories often came full circle and were in fact very relevant to the topic we were discussing. So it is a different form of communication that takes a little bit of getting used to, but lots of knowledge to be shared. Being on country is really, really important. I noticed a big difference in the knowledge that was shared when we were just sitting around at base talking about burning versus when we were actually out on country doing burning. Being able to physically see everything that was happening is when they were able to share with me knowledge with great detail, and it was really very impressive. There are, of course, a lot of cultural differences that need to be taken into account. So in particular, there's very complex family dynamics, especially between men and women rangers. One example is some of these men and women are what is referred to as poison cousins. So this essentially means they have an avoidance relationship with one another. They cannot look at each other. They can't say each other's names. They cannot be physically in the same space with one another. So this needs to be taken into account when you're planning any outings or activities. And finally, with all of this in mind, the last thing I would say is flexibility is key. So just making sure that you've set aside a lot of time because anything can come up and you are working with people who have very different ways of doing things. They might have different priorities than we do. So it's important to just be very flexible with that. So that's all I'm going to share with you today about my research. I was actually very lucky to have the opportunity to share this research at the WCRP Open Science Conference in Rwanda. So you can see me there with my poster, but I'm going to share with you now just some more general impressions from that conference. So on the topic of extreme events, one of the main things that did come out of that was that extreme events are going to disproportionately affect the global south, and climate science researchers in the global south need greater resources and technological advancement to progress their research. That it was the first conference I've ever been to that had such a large presence of African delegates in particular, with it being hosted in Rwanda. But many of these delegates, as I was talking to them, they never even left the continent of Africa. And I think that's something that we take for granted here in Australia. So there was a big emphasis as well moving forward on global North and South solidarity, and as well the need to value and include knowledge of local and indigenous communities in our climate science. So thank you very much, and I'll pass back to Simon now.
Thank you very much, Katie, because I saw some really positive messages in there around, caring for country, being out on country, making those connections. It's so important to the mandate of the National Environmental Science Program, the Indigenous partnership work we go into. And, as hub leader, I'm really proud of you, Katie, for getting out there, challenging yourself, making those relationships, and doing some great work out there with the Mimal Rangers. So thanks for that, and really glad that you had the opportunity also to go to the World Climate Research Program Open Science Conference. Just lost my control of the slides momentarily. Thank you, Tani. On that, we started out with some doom and gloom. I gave some examples, Andrew gave some examples, but, looking at that work Katie was doing, I did mention, there's some good stories behind this, and I want to talk a little bit about optimism. I still don't have control of the slides. Sorry, Tani. I'm just trying to regain that at the moment, but my daughter, I didn't see her last birthday, Christmas season for me, but I was speaking to her on the phone and she said, "I've got a present for you, Dad." And I said, "What's that?" And she said, "Optimism." And I was kind of skeptical. I said, "What, you're just giving me the word optimism?" And she said, "Yep, go and try it out, Dad. Come back in a year, tell me how it went." So I drew up a little circle and put some eyes and a mouth on it and said, "Oh, look, I think I've invented this optimism symbol that's actually just the smiley face, but stuck it on my wall and have tried to remember it across the year." And she is delighted to hear that today I would be bringing that optimism message. So a few things that happened this year that make me optimistic, and one of them is what Katie was talking about, the World Climate Research Program Open Science Conference. It's a really important conference. It only happens once every 10 years, and as Katie mentioned, a huge delegation from the Global South, a huge delegation from Africa present there. And I'm not going to go through all of this slide. I'm just going to go around the circle in the middle, starting at the top, because it also brings together a bunch of great scientists, and you get to hear about the advances in climate research that have been going on. I attended online, which was nighttime in Australia, but it was so interesting. It was keeping me up very, very late, till 2 or 3 in the morning each night, to see the advances in science that are still carrying on over the last decade. There's so much more work to be done. I'm really proud that the Climate Systems Hub is a part of that work as well. There's a second theme to the conference, which was human interaction with climate. It's written up as climate change drivers and societal impacts at about 3 to 4 o'clock on that circle there. And that is around the translation of the science we do to actually make it relevant to societies and the communities that we serve as scientists. So that's really exciting to see that going forward. That was a major theme of the conference 10, 11 years ago, the equivalent conference, and huge advances have been made in understanding societal impacts and producing climate services as well. So that's the third one I want to go to at about 9 o'clock on the big circle in the middle there, co-produced climate services and solutions. And that was my involvement in the WCRP conference, was as a co-chair on a session around climate knowledge co-production in a decision and policy context. And I think that's a space where the Climate Systems Hub is working both with federal, especially through Department of Climate Change and Energy, the Environment and Water, but also through our state knowledge broker partners that we have in the hub, so across Australian states as well. That idea of co-design, co-delivery, co-production, bringing the scientists along on that journey with the stakeholders whose needs we are trying to serve, and all being together in ideally in the design and running of the project, so that we're always going to that pointy end of, how best to serve society with the science that we're doing. I felt really optimistic that the Intergovernmental Panel on Climate Change met in Nairobi during the year to elect the new Bureau for the 7th cycle. And in, I believe, January next month, that new Bureau will be meeting and determining what kind of assessment reports and special reports will be coming through the 7th cycle. Why I feel optimistic about that is because the UN Framework Convention on Climate Change, all those nations that are signed on haven't walked away. They're still going with this process. I think it's really important. It brings together a coordinated international assessment of climate change and climate science, which is so important to build our decisions, not just as people and societies, but also as a global community on how we go forward in terms of emission scenarios, be they high climate change scenarios or lower climate change warming scenarios. The understanding of that and the assessment of that is so important. So that's something to be optimistic about. When people go to the IPCC and say the high scenario, the low scenario, what's it going to look like in 2050? What's it going to look like in 2100? A lot of that falls back on the climate modelling that we do, and we do it in the hub. We do it here in Australia and have since for 30 years or so. The Australian efforts in international climate modelling space. It's coordinated once again through World Climate Research Program in the Coupled Model Intercomparison Project. I'll just call it CMIP from now on. CMIP is aligned with the IPCC assessment cycle. So as we go to IPCC 7th cycle, we are looking at CMIP 7 in the modelling space. A lot of thought going into the kinds of models we'll be running in the future. I think the hub has a really important role to play with our national access climate and numerical weather prediction model in driving forward and setting the seeds for a really good submission from Australia into CMIP 7. And having that understanding of global climate modelling feeds a value chain through downscaling to regional projections and getting down to community level of what this future climate change might look like and getting a better understanding of it. All very important work. It was great that the Australian Meteorological and Oceanographic Society celebrated their 50 years this year, and I was a part of that at Melbourne Museum the day to celebrate that. It was the Royal Meteorological Society, so from the UK, Australian branch, RMSAB. In the 80s, it became AMOS, and it followed the Canadian model where they split out from the Royal Meteorological Society a few years earlier and became CMOS. And the point there is it's meteorological and oceanographic. So even back then in the 80s, there was the wisdom and the insight of scientific leaders in this country and others that the real scientific challenges going forward would be in the climate space. And that's why it was so important to bring the meteorological and the oceanographic communities together in that body in Australia. So there was a really nice celebration of how much Australia has contributed globally in terms of climate science over those decades, and a lot of hope about where we might be going in the future as well. So that's another thing to be optimistic about. I think coming to an end here now, a few things have been bubbling up. The DQ, the federal department, have embarked on this process around our first Australian national climate risk assessment. A lot of work going on there. Indeed, that's anticipated that will lead to Australia's first, federal national adaptation plan in the years coming after the National Climate Risk Assessment. And it was wonderful to have the Assistant Minister for Climate Change and Energy at the Climate Adaptation Conference that the Hub, through its Climate Adaptation Initiative, convened in Adelaide this year, where over 400 people came together to talk about climate change, but importantly, to talk about what to do about it. So very grateful to our Climate Adaptation Initiative leader, Sarah Bolter, for all the hard yakka that went into bringing that, I think, very important conference in Australia together to start to, or continue addressing those questions around what can we do in the face of climate challenges. Last slide, and everybody knows that the dice are loaded. That's the first line of a Leonard Cohen song, if you didn't get that. But the dice are loaded is a phrase you hear in the climate change space in talking about extremes, and why we are having, perhaps more often and more extremes, because the underlying trend of the climate change, the global warming, is underneath what used to be variations in weather, basically, and how that translates into longer term climate. The dice are loaded by the climate change signal. So I've got two questions there. One, is climate change real? Last month, or a couple of weeks ago, I was at the barber having this haircut, and the barber was talking to me about climate change, and he asked me, is climate change real? And I didn't give him too much of a serve because he was holding a pair of scissors to my head, but I did note, as I was, in that position, I thought, oh God, I used to be asked this question, and I've road tested this with a number of other climate change, climate scientists since. I used to be asked this question all the time. Weekend barbecues, here, there, everywhere, wherever you met someone who heard you were a climate scientist would ask you that question. And then, I thought, the barber just asked me that, but I have not heard that question for 5 or 6 years. And that goes back to the everybody knows, the fact that we aren't getting asked that question anymore. I think that's something to be optimistic about. That's something to be very positive about, because now the question has changed, and it's what can we do about it? And that goes to the adaptation. That goes to some of the work you were doing, Katie, out on country as well. I think that's where I'd like to leave 2023, with a positive outlook on things that are happening. So thank you very much. And I think we are good to go to questions. And I've just popped out the question box. And we have one there from Neil Marshman. A number of today's impact charts show a breakout in outcomes over the past few years. Is there a non-emissions related explanation for this, or will the breakouts continue to accelerate? So I think, Neil, you're talking about those really, high points on some of those charts that are looking different to 30 or 40 years going back. You suppose this is a question of linear responses versus tipping points. I'm going to challenge you, Andrew. Would you like to have a crack at that one for Neil?
Sure. I think it might depend exactly, which graphs you're looking at, because with the Antarctic sea ice, there's been this massive decline, and Simon can obviously say more about this than me. But I think there is, it's such a big change that there's a lot of research going on as to try and understand that change, including research being done in Australia. In terms of the global temperature spikes, there is an element of that being not just related to greenhouse gas emissions increases, but also these other factors I briefly touched on, all kind of coming together at the same time. The increase in solar activity, the Hunga Tonga volcanic eruption aftermath, all of these things kind of adding fractions of a degree on and adding up to see these big spikes. But we are, of course, the other important thing to remember is, work from PEP Canada and the Global Carbon Project published recently shows our greenhouse gas emissions are still at record high levels, which means we are warming the planet at a record high rate. So we should expect to see big record-breaking extreme events just because we're warming the planet so quickly through our record high greenhouse gas emissions. So it kind of depends exactly what you're looking at. I don't think in general there's much evidence of breaching tipping points yet, but particularly with the sea ice, there's a lot more that we need to understand.
Thanks for that, Andrew. And yes, there's been a lot of talk about tipping points this year, and some of the things that might happen in the future: collapses of forest ecosystems, collapses of coral ecosystems, collapses of major circulation features like the Atlantic Ocean overturning circulation as well. But agreeing we're not quite at those tipping points yet, but it's certainly something to be aware of in the future. And some of the extremes this year have been quite surprising in their magnitude. So you do wonder where the world might be going. But just going to move on to the next question here. It's to the panel, and it's given as tongue in cheek. So, but is the interaction between Indian Ocean dipole and La Nina, or let's call it ENSO perhaps, causing the sudden increase in climate change denial? Eddie, I was giving the exact opposite message in my last slides there, that I think, at least in Australia, that I'm seeing a decrease in what might be called climate change denial. But I'm going to flick back to you, Andrew, again with the take on this question around some of the variability that's happening in those major large-scale climate drivers on Australia, and how that may play out in short-term events. You've already alluded to it in your webinar, but if you'd like to reinforce or add to that message.
Yeah, I think, Australia obviously experiences lots of different influences from different climate modes, including and so El Nino and La Nina and the Indian Ocean as well. And these are quite complicated, and sometimes the responses to these interactions are quite hard to predict. And yeah, they're quite diverse as well. So not every El Nino results in a really dry, hot summer, but it does raise the probability of a dry, hot spring and summer period. I haven't personally observed any increase in climate change denial recently, but yeah, as I say, I haven't seen that myself yet.
Thanks, Andrew. Mandy Hopkins asked a question around to Katie, and I know, Katie, you've answered this in the chat, but I thought I might just bring it out to raise the profile around this, and also if you wanted to add anything else. So the question was around, have you thought of using traditional owner observational data as well. Most ranger groups keep very good observations, and it is much more relevant to country than Australian weather station data. So, Katie, is there anything you'd like to share with the audience there?
Yeah, so suddenly when I was doing those yarning sessions, we were yarning not just about what the indicators are, but what kind of changes they've been observing lately. And certainly there was a lot of changes that they had observed. I mean, this was part of the reason why that prompted us doing this study in the first place. So we are trying to incorporate as much data directly from the traditional owners as possible, which is one of the benefits of having this partnership with the Mimal Rangers, and getting them as involved as we can. But what I did just point out is that so they started doing their burning in 2015. So it's not a very long time to go back historically. So that's what we're using, complementing the traditional owner data with data from the weather stations, etc.
Thanks very much, Katie. And I see a hand up from our Hub knowledge broker, Ramona Della Posa, coming online there, please.
Thanks, Simon, and thanks for the great talks, everyone. That was really great. I had a question either for Simon or Katie, or Andrew, if you want to chip in. It's just on your reflections of attending the World Climate Research Program conference. And I know it's mentioned a bit that, you know, the Global South is going to have a lot of impacts, you know, maybe more than other areas, but we also have to, you know, increase our climate science capability if we're going to help to try to address them. So wondering if you could reflect on, you know, how we might use the international community to help us do that in Australia, because we are trying, you know, in national coordination efforts, the National Partnership for Climate Projections that, as some of you know, I'm heavily involved in, and I really am passionate about trying to bring the climate science community together to improve our capability. But, you know, is there a way that we can use that relationship that I think, you know, both of you would have been exposed to?
Thanks, Ramona. And if it's okay with you, Katie, I'll have a first go at that, because I've been closely associated with World Climate Research Program bodies in ocean model development and coupled climate model coordination over the last 14 years or so, and seeing more widely also how Australia contributes to, but also gains from international coordination. It happens more generally, but I think the WCRP is a really good example where Australian scientists have been engaged for many years in that body. And sure, we put a lot into it as Australians, but doubly so, we get so much out of those interactions internationally in, we're a small community here in Australia, and what we gain through international engagement is far and away above the cost of having those engagements, be it in the time people put into it or sometimes the travel as well. How we can further utilise this for, and you had the example there around the Australia's National Partnership for Climate Projections. I think that there's, further examples around, how we do co-design, how we go into knowledge brokering in the hub as well. So, how we engage with stakeholders in determining the scientific research and the way that we package that research and try to make it as relevant as possible. I think there's still a lot to learn internationally around best practice there, but I think we're also in some ways at cutting edge in demonstrating some really good practice there as well. But certainly these challenges are something that we shouldn't be trying to do on our own, that international engagement is hugely important to our community. Katie, I'm going to hand over to you if you have reflections as an early career researcher walking into that space. Did it open your eyes in any way or help you?
Yeah, well, I was just going to comment that one of the outputs from the conference was the Kigali Declaration. So that was like, there was a big discussion about that on the final day. And I actually just got emailed about it yesterday, the final draft. So I'm not sure when it's going to be public, but it does outline some of the ways that we can work together to address some of these issues. Yeah.
I'm just going to end up here reflecting. I'm going to ask you and Andrew and Katie as well. You know, one of my key takeaways this year is that you know, things in the climate space are moving pretty fast, and it's only by coming together that, you know, we have our best opportunity to face forward challenges. And I'm talking about things like the Climate Systems Hub, which brings together universities with government agencies, CSIRO and the Bureau, and the state knowledge brokers in there as well, and the federal government. All together, we are so much stronger than if we are alone. So united in the face of these challenges, I think, is a key reflection from me on the year. And I'll go around the ground. Andrew, looking back on 2023?
I was going to say something very similar, actually, Simon. Like we've seen, whilst we're seeing really major extreme events happening around the world, the science is progressing quite quickly. We're coming up with new ways of examining extreme events, and there's lots of, especially after COVID and the pandemic, there's, I think, a lot more appetite for collaboration, international collaboration and working together now, as well as collaboration through centres like the NESP hub, and also the new Centre of Excellence on the Weather of the 21st Century as well, which many of us are involved in. So I think it's climate science is progressing a lot. Our understanding of the risks and processes associated with extreme events is improving all the time. And we just really need to see the policy catching up in some ways.
Thanks, Andrew. Katie, giving you the last word here.
Thanks, Simon. Well, as an early career researcher, I am like pretty new to the field of climate science, but I would say even since I started my candidature, I've noticed a growing interest in working with traditional owners in particular, which I think is really fantastic and really exciting way forward. So if we can continue developing more partnerships like that to bring together traditional knowledge with Western science, you know, that's a very exciting thing to come.
Thanks so much, Katie. I'd like to finish up by thanking our communications team for putting on these webinars out to a wide audience, which has been growing across the year, and finish up by thanking you, the people who are joining these webinars, and hoping you're getting something out of it. Please feel free to reach out to us afterwards if you have any further questions you'd like to take offline. But with that said, best wishes for a 2024. Thank you.